Hi everyone, I'm Adam Maltese and wanted to welcome you to the Microbit Deep Dive Part 1. I'll be teaching this with Barbara Yarza, who will be joining us a little bit later. And what we thought we would do is start with a little bit of a review and then jump into more new content as we go. And so we're going to do that now, and let's get started. So, just as a little bit of background, what we are thinking of and hoping you'll embrace for this is this idea of tinkering to discover. So, while we will be presenting to you a lot of information, the idea is that you will then play with this information and go from there to explore different ways that things work, explore new things that we haven't presented, and through that exploration, you're learning different things about the interface, about the hardware, about yourself as a learner, and hopefully you'll bring some of that back and share it with us. We are putting you in the position of the learner, and the idea is that through doing that, you will then experience what your learners might feel in the future, and then you can better prepare based on that. So like I said, we're going to start with a little bit of a review. Very simply, there's a difference between the microcontroller that we are going to work with, a microcomputer, and then a computer like a laptop, desktop, or even some of the more advanced tablets that you might be taking this course on. So what we're going to be working with is sort of the low end of this, which is the microcontroller. And microcontrollers are really good at doing simple things and doing them repeatedly, doing them maybe for a long time. But they cannot do things like answer your email, go on the web, watch stream TV or something like that. You might be familiar with, microbits are at the sort of early stages of this, right? They're a microcontroller. Arduinos are microcontrollers as well. Something like a Raspberry Pi is in the middle. It's what we might call a microcomputer. So it is a full-blown computer and can do most of those things that you're used to doing on a daily basis. It just does it in a smaller footprint. And so that's great for when we want advanced capabilities without needing to use or spend the money for a bigger computer. So we have used this before where we might want to have some sort of sensor out in the field or relaying information from a field sensor that's like an Arduino or a microbit through the Raspberry Pi, and then it is emailing the results or posting them to the website or doing something like that. And so you can think of it from sort of very simple tasks to more advanced tasks. And the microcontrollers are down at that simpler end. They can still do a lot and they can do it well, but again, they can't do all the functions and functionality of a computer. In this course, we're going to be focusing on the microbit. And you might have old versions of a microbit that might be version 1. We sent you version 2 to work with. And there are some small differences. There are a couple bigger differences that I'll talk about here, but they're mostly small differences. And most of the functions and things that we'll talk about will be the same across these. For sure, there will be a version 2.5 or 3 coming out at some point, and I'm sure that will have even more upgraded capabilities. The main difference that we're most excited about with the version 2 is that it has an onboard speaker and an onboard microphone. Previously with version 1, you could not record anything in terms of sound, and any sound that the microbit played had to be played through through sort of earbuds or through some sort of audio jack that you connected to the pins on the bottom of the board and then you connected it to your headphones and you could hear it from there or your speaker. So this one has a speaker on board and a microphone. Of course, they're not studio grade. They're not going to give you great quality, but it does increase the capabilities quite a bit, which is great. The version 2 also has a capacitive touch component, which is the logo. So the little two microbit eyes at the top that you see on the right, you can touch that, and that can be considered another input, where when it is touched or activated, it could trigger other functions. On the microbit version 2, you can use the button that's on the back, which has always been there to do a reset of the board. You can now do that with a long press. You can do that to turn the microbit off. This is really nice, particularly if you have the microbit on battery and you don't want it to just sort of continue to run and run and run. You can shut it off and still leave it connected to the battery. In the past, you had to unplug it from the battery. You'll see in version 2 that there are some notches below the 0, 1, 2, 3 volt and ground. And those are to better enable alligator clips to connect to the microbit and hold those connections. Probably also helps with sewing or other connections that you might want to make there. And so, that's a small upgrade in the design. And then, as far as I know, there are upgrades to some of the sensors and the processor on the board that allow a little bit more accurate measurement or faster computation. There's a link included here, and that takes you to a little bit deeper dive from one of the suppliers that talks about the similarities and differences between the boards. You probably won't be able to notice too many differences, but I did want to show you that version 1, which I have here, that's the front and the back, is identical in dimensions and looks very similar except for the notches on the bottom and that capacitive touch logo to this, which is version 2. And if you looked closely at the back, you would notice a few differences there. But the main difference is that you would notice those notches on the bottom. That's the main thing that I use to recognize the difference between version 1 and version 2 there. Otherwise, they really look quite identical, and they will connect the same way. They will use the same battery connector if you want to use that. And yes, so they sort of build on each other, and they, in many cases, since I'm not aware of all of these, they will work with the same peripherals. So I'm not going to go into all of the different functions that the microbit has. We'll do that over time. These images do a great job of showing the different functions that a microbit has and the different processors, inputs, outputs, those sorts of things. So I do want to spend a few moments here. You may connect to the microbit through Bluetooth or through USB. USB is always going to be a bit more reliable in terms of connection, but you can definitely connect through Bluetooth. I can't remember if you can make the first connection to a microbit via Bluetooth, but you can definitely make future connections through Bluetooth. Like I said, this is version 2, so it has a touch logo. The main thing that people notice on the front screen is the 5x5 LED matrix that you can turn those lights on and off. You can increase the brightness of them. And then there are two buttons, the A and B button on either side. And those can be, each one can be an input, or you can press both of them at the same time. And that can be considered an input, a third input there. There are the pins at the bottom. There's actually more than the pins that are drawn here. Each little space between the lines can be used if needed. And when you take the microbit and plug it into a peripheral, like an edge connector, it can connect to all of those and sort of break them out to be more useful for a variety of functions. The main ones that you need, though, are labeled. So 0, 1, and 2, and then there's the 3 volt and the ground connector, which might be required for connecting to different lights or servos or different things, and we'll explore a little bit of that in the class. If we look at the back, you can see the radio antenna in the corner, and that's used not to receive radio signals from AM, FM, but to connect to other microbits. And that's a really awesome way to use these, and we'll talk about that. There's the microphone on the back, there's the speaker, you see the processor, and I believe the temperature measurement is still made within the processor, so that's where that occurs. There's a compass and an accelerometer, and then toward the top you'll see the USB connector, the power button, and then the socket where you would connect the battery or other power connection. So there are a number of different ways that you can connect to microbit. One of the reasons we really like it is for all the functions we just mentioned. But another benefit that has come about is that since microbit is so widely used and loved, there are a lot of different interfaces that have been created to connect to it. So there are surely more interfaces than the ones I'm going to talk about, but I'm going to mention a few of the more popular ones and the ones that we have worked with, and just quickly sort of mention them so that you can explore them. So the main one that we will work with in this class, and the main one that we have experience working with, is Microsoft MakeCode. So MakeCode is an interface that Microsoft has created, and through that you can connect to a number of different microcontrollers and other things, and you can use block-based programming to make those things to operate. And so that's the main one that we will work with, and we'll explore that interface more. Microbit is experimenting with creating their own interface called the Microbit Classroom. And in Microbit Classroom, it's not necessarily its own interface to connect, but it's like a shell, and it helps educators to oversee a group of people working. So whereas Microsoft MakeCode is really the main way that a single individual will be working back and forth. Right now, there is not really an easy way for multiple individuals to be working together, not necessarily at the same time, but working together in the sense that they're all working on the same project. So Microbit Classroom is a great tool to use for that. It's continuing to be upgraded, which is great. And the main way that I have used it before that I think is most valuable is if you have a code or a couple different pieces of code that you want to push out to your classroom, you can have those up. It will actually use MakeCode as the main interface, but then you can use Classroom to sort of push that out to your class, the people who are registered in the class, and they will see it. And then you're able to sort of see the work that they've done in that space. So it's great for that. And it looks like there's a few more things added where you can more easily access some of your own work and some other work like exemplars that they have created for different activities. Beyond those, there's still more. And so if you're very familiar, or your students are very familiar with Scratch, there are some ways that you can program in Scratch and then have that trigger things on the microbit. And so we have that here. If they're maybe at the other end where they're already working in JavaScript and Python, there are ways for them to sort of connect that directly. What we have here at the bottom is the Python editor for the microbit. And that's a nice way. It still has a lot of support for learners who are just learning both microbit and Python, but you can use that to write out the functions that you want in code, and then again connect to the microbit that way, which has been it's worked well when we've used it. The other one that I want to mention is microblocks, and that's in the upper right here. Microblocks is fun and pretty easy to use. It's also really based in block-based programming, and I have used it mostly when we've been playing around with it and then trying to also use it to tweak some functions. And what we were using it for was to try to increase the rate that the microbit was recording data so that we could use the microbit for a virtual egg drop. And so, so again, it's fun to explore. It has a lot of functionality. It's good user support. And so I'd encourage you to take a look at that and see what's there. So here, what we'd like you to do is to pause, go to that slide that I just showed and the previous ones, and primarily explore the interfaces that are other than MakeCode, since we'll be exploring that one in this class. So we want you to take a few minutes to explore Microbit Classroom, Microblocks, the Python editor, and Scratch connecting to Microbit. And so not that you have to, we're not asking you to do anything in those as of yet, but if you can go there, get some first impressions, play around a little bit, see what the interface looks like, see what looks familiar, what doesn't look familiar, even maybe try to connect your device, and mostly think about which of those might be a useful tool for you and your learners. And then go ahead and record those first impressions on Flip, and that'll really be your first task for the deep dive. That was a decent amount of background. Now we want to get actually into thinking a little bit more about how to use the microbit. So when we talk about computers or computing in general, we often think in terms of inputs and input devices, sort of what the processor is going to be doing with those, and then outputs. So again, we can think about this really across all computing devices. For the microbit, we will try to break some of the content into these separate areas and think about it as such. And there's some labels in MakeCode and other places that match this. But if you can think of, like the image shows, for a typical computer, a keyboard, mouse, microphone, things like that might be inputs. And then what they are putting into the computer might stay in various amounts for different lengths of time in the computer's memory. But usually the computer is doing some process to either make that show up on the screen or trigger some other function. And so that's where the sort of memory and processing come into play. And again, the microcontrollers we're working with have much lower processing and memory capability than the computer you're used to working with. And then there's outputs. So things like things that you might see or hear or sense are outputs, but also things like for a computer, when you hit the K key and a K appears on your blank screen, that is the output. It's showing this character. And so if we think about things in this way, it can help us to sort of package or bin these different features in such a way that you can think about, using different inputs. The computer's going to process things regardless of what input it is. It's going to process things the same way, maybe, and then how that's going to be related to the output. Either it's just going to trigger an output, or somehow the amount of an input or the type of an input is going to play a role in determining what the output's going to be. For an example, if the input is, something that's going to measure how hard you're pushing on it or how fast you're pushing, and the output's going to be the brightness of the light or the volume of the sound, you can imagine that the harder you squeeze, the higher the volume. Or the faster you push, the brighter the lights are going to be. So there's a couple different ways you can have those things relate, and that's all going to happen really in the processor. Okay, so in make code, there's going to be different drawers and functions that you have access to. And again, we're going to just sort of ask you to play with these, but you can look through them, and not all inputs are in the input drawer, and not all outputs are labeled output, but usually functions of similar type are color-coded in that way. And as you can see here, frequently the inputs have a something that says, when this input is triggered, and then you could think of it that a process is going to happen, and then there's going to be some output. And so the inputs often look like, some people say they look like a crocodile or an alligator mouth or something like that. And that's sort of bracketing around whatever the process and the output is going to be. In the middle, you can see some of the functions from the music drawer, and those would fit into the inputs on the left there, and again are going to be some sort of output. And then on the right, you can see things like a loop and a pause, and those will be not necessarily functions themselves, but they will contribute to your code in a way to make it do more of what you want to do. Just one more thing, I would say that music is one of the outputs, of course, but there are other outputs, and we'll talk about those next. Just as a little bit of a flashback, this is the make code screen. And so those options that we were just looking at, you can see in the middle left side there, to the right of the microbit simulation, you can see these different drawers that are labeled and color-coded. And again, some of those will have inputs in them, some of those will have outputs, but that is where you're going to sort of open and close those repeatedly. And when you find what it is that you want, or you think you want, you can grab that and drag that block out onto the workspace, which is the area to the right. And then you can work on connecting those pieces to make your program. I wanted to just give a quick walkthrough in case you've forgotten, or in case you haven't had a chance to do this before. And here I'm on the Microsoft MakeCode microbit page. What we want you to do for the challenge is to go in and, like we said, create a story with some icons and some music. So let's say you want to get started here. Well, the first thing you're going to do is you're going to click on New Project. And you can say, this is the MEC Deep Dive 1 or something like that. And hit Create. And then it takes you to where you'll be doing most of the work and spending most of your time. And so you can, in the upper right corner, you can see that it has a sign-in option. That's relatively new. That's really great in the sense that if you are working across different computers, it can keep track of your account and some of the programs and things that you've created over time. If you're working on the same computer, it will keep track of those just fine. But again, it still might be worth signing in to keep track. So in this screen, we have a couple important things. On the left is the simulator, and that's where we're going to sort of test the code and see if it's doing what we want. In the middle left is the drawers or the set of functions that we talked about before, and we'll explore those in a second. And then the workspace is the biggest gray area on the right there, and that is where we will drag the blocks out and sort of come up with different combinations of code. At the top, you can see blocks is highlighted. If I click on Python, it toggles over to that option, or I can switch to JavaScript if you were going to be coding with like a text-based coding, then you could use that toggle. But since most of you, I think, will be using blocks, we're going to focus there. And what we asked you to do is to think about using inputs, right? So if we click on input, you'll see a variety of inputs. You can shake the device, you can click the button. If we choose this, you'll see that there's shake, there's sort of logo up, there's all these different positions. So that might be one way you could set the input. And then one thing to note is sometimes for some of these drawers, there are so many things, right? It's like some of our drawers in our rooms, they have so many things in them that like you have to go into like a secret place to find even more. And so sometimes they have this extra drawer that pops up and that has other functions. And then sometimes down at the bottom, there will be certain functions like this one where it says set loud threshold, and that's listening to the through the microphone to the ambient sounds, that if those sounds are above a certain level, then it would act as an input and trigger some other function. So some of them are just for microbit version 2. For the most part, they are available for all of them. We said we'd like an input. We want some music. That drawer's, I won't say self-explanatory, but there's a variety of things you can explore there, right? So we can pull that out. And then we can click in here and click different melodies. And so that can be our song if we want. And then the other place that you might go is to create your icons. If you pull out the show LEDs and you click in these boxes, then you can make your own picture of whatever it is that you're trying to make. And then you could slide that in so that when the trigger happens, it goes through the 2 outputs that you have. So this is going to play the song, and then it's going to show the image. That's the brief intro that I wanted to give. If I did want to download this to my microbit, I can use this big button over here to connect to the microbit and get it to actually come out on my device, which is great. And then if I wanted to share, like I showed before, I can use that project title, and if I hit share project, it gives me a variety of different ways to share it. And for copying the URL and pasting it in Flip, then you can, hit that as copied. And when you paste that in Flip, then it will bring anyone who views it, if they want to, they can come to this screen and they can see what your code does sort of through the simulator. And then if they want, they can actually see what's under the hood and see how you coded those things to happen. Now that we've given you that background, we'd like you to jump in and try to explore and see if you can create some story with some of the functions, the inputs and the outputs that we just talked about. So I know we didn't give you a lot of background, but the idea here is to explore. You can't hurt anything, and see what you can come up with. The first part of the challenge we're going to ask you to do is to try to come up with a sequence of emojis that would tell us something about you. We want you to use at least 3 emojis or icons that you create that would tell at least where you're from, what grade you typically work with or what grades, or the content area, and then something that's fun and interesting about you as a human. And so we want you to create those, so we don't want you to just use the happy face, the smiley face, and the skull or something like that are already built into microbit. This helps with a couple things. One, it helps you think about how you can turn bits and pieces of a story you might be interested into an icon or a graphic. It forces you to explore how you might create some of these on your own, and particularly using the 5x5 matrix to be able to turn on and off LEDs in order to create a picture. Again, having that constraint is actually really interesting to have to think about rather than a bigger and more functional space for you to create an image. So go ahead and try that. That would be the first thing that we ask you to do. The second part of the challenge is to create a bit of a soundtrack. So we'd like you to create your own song or take a song that exists and modify it in some way and have that song play in conjunction with the emoji or icon sequence that we just talked about. So you're creating a story that has both images and audio in the sense of sound that's going along with it. That audio might just be a meaningful song to you. It might actually go with each change in the icons that you have in there, or it might be some other approach. But ideally, we want this music to play while those icons are showing, not strictly before or strictly after. And that sometimes can create a little bit of a challenge, but we're interested to see how you can solve it. So with that, we want you to go ahead and get started and jump into the code. So you can search make code, or you can grab the URL here and go ahead and give this a shot. And then just as a little bit of a reminder, when you are done with your code and you want to show it to us, we'd like you to create a little flip video that shows what it is that you've created. And especially this is helpful as instructors, if you can use this screen, which reminds you to, on the make code page, if you go to share and then you generate the URL to your code, you can copy that URL and paste it into your Flipgrid video. And that will help us if we want to go and see the code, or if someone else wants to see the code. It sort of keeps a record of that. And then we can help troubleshoot if it's not working out for you, or again, other people can learn from the way that you did your code. That's it for now. Thanks so much. We're excited to see what you create, and we'll see you again soon.